Welcome to Paradox Lab. The universe did not begin in silence, but with a cosmic rage. In a fraction of a second, shorter than the blink of an eye, the void was torn apart. From that terrifying epicenter, a microscopic entity was born, so tiny it was almost invisible. The hydrogen nucleus, the very first building block of all matter. For the past 13.8 billion years, these primitive, tiny atoms have survived fierce cosmic upheavals to be present everywhere around us today. But how did they do it? In stark contrast to the quiet night sky we see now, the early universe was an incredibly dense, glowing mass, hot enough to break every law of nature, with temperatures reaching billions of degrees Celsius, a number beyond human comprehension. Entire giant galaxies, brilliant stars, and the Earth itself were compressed into a point smaller than a grain of sand. Even the concepts of space and time had not yet truly taken shape. Scientists call this brief, chaotic moment the Planck Epoch, which lasted a mere 10⁻43 seconds. Like a fully compressed spring, the universe suddenly burst outward, flashing and expanding at a terrifying speed, faster than light. In an instant, that tiny grain of sand transformed into a vast ocean of space, blazing with countless microscopic fragments darting around. Among these fragments were quarks, the most fundamental components that make up matter. These entities had very peculiar behaviors. They feared loneliness. Instead of standing alone, quarks danced and collided frantically in the immense heat, searching for a connection. However, this effort to merge was not easy. For every quark that appeared, the universe created an identical replica with an opposite charge, known as an antiquark. These two were like fire and water. A mere touch would cause them to instantly annihilate each other, leaving behind no trace except a flash of searing energy. Logically, everything should have ended in the absolute balance of nothingness. But due to some mysterious bias of creation, the scale was tipped. For every billion pairs of particles and antiparticles that destroyed each other, only a single lucky quark survived. Thanks to this, their numbers were just enough for matter to dominate. Yet, these solitary survivors could not build any structures without a binding force. Gluons, force-carrying particles acting as super-strong glue, were born to lock the quarks together. From this bond, a fateful combination began. Depending on how these pieces were arranged, different components were formed. Among them, a special trio came together to create the proton. Newly born, the hydrogen proton found itself in the middle of a frantic crowd. Surrounding it were countless smaller, lighter particles darting past like ghosts, the electrons. The billion-degree heat prevented them from getting close to one another. Electrons simply zipped past the proton, moving so fast that no interaction force could hold them back. Not only matter particles, but even light was struggling to find an escape route. However, within this suffocating density, light rays could only travel a short distance before colliding with electrons or protons and bouncing off in another direction. The universe was like a thick fog where light was imprisoned in an endless series of eternal collisions. At this point, the poor hydrogen nucleus could only wait patiently. Time dragged on until 380,000 years later. Space stretched out, gradually pushing these tiny travelers further apart. The once scorching environment began to cool down, dropping from billions of degrees to just tens of thousands. As the fever subsided, the universe lost its initial brilliance. The color gradually shifted to yellow, then deepened into the orange of a late afternoon. Finally, when the temperature hit the 3,000 degrees Celsius mark, equivalent to the heat on the surface of today's sun, the entire space was submerged in a melancholic deep red. The solitary hydrogen nucleus could clearly feel the silence slowly taking over. As the heat faded, the collisions also became sparse. In that dim red haze, light no longer had enough energy and quietly faded away. A silent night began to blanket everything. The nucleus stood there, wondering if it had been abandoned in this eternal cold. Then, a strange urge suddenly arose from deep within its core. The proton heard the call of its missing half nearby. A negatively charged electron was rushing toward it. For hundreds of thousands of years, the proton had watched billions of similar figures breeze past. But this time, everything was different. The other friend no longer had its previous frantic speed. It was tired, slowing down, and appearing vulnerable. When the two entities came within a certain distance of each other, the electron was caught by a strange force that we now call the electromagnetic force. Under the perfect coordination of cosmic laws, the electron entered an orbit around the proton, moving ceaselessly and never separating. From a bare, solitary, and boiling nucleus, the proton had now completely transformed in nature. It was officially born under a name that would be etched into the history of all things: the hydrogen atom. As soon as the first atom formed, a massive chain reaction immediately spread to every corner of space. Billions of other protons simultaneously captured their own electrons. At this very moment, the destiny of the early universe changed. As matter blended and settled into neat atomic structures, space suddenly expanded immensely. The thick fog vanished. The light particles that had been suppressed for so long finally saw an open, straight path ahead, completely unobstructed. At a speed of 300,000 kilometers per second, light broke free simultaneously, darting straight into the vast void. Deep behind, countless other brethren were also present, all enjoying the newfound freedom of a newly formed order. Escaping the chains of matter, light surged in every direction, carrying the encrypted blueprint of the universe from its exact moment of birth. Imagine these rays of light as the ultimate records sent from a fiery primordial era into the future. They traveled resiliently through space for billions of years, and although they weakened and cooled, they never completely extinguished. Later, when humans used advanced equipment to collect these remnants, they called them the cosmic microwave background radiation. We are incredibly lucky to see the first photograph of all creation right as the cosmic fog lifted, an eternal proof of the era when hydrogen, the persistent traveler, had just completed itself. As the last rays of the explosion faded into eternity, a new entity slowly revealed itself. The universe was now sinking into a deep darkness, free from the collisions that once generated illuminating energy. While the stars had not yet formed, hydrogen found itself standing in an absolutely freezing void. Though complete and free, it had to face an unprecedented loneliness. The Dark Ages had arrived, and time simply drifted through the silence of nothingness for 1 million, 10 million, and then 100 million years. Before continuing, CD Media would like to introduce the main sponsor of this video, ExpressVPN, the world's leading VPN service. One account can be used for 14 devices, encrypting data to help you feel secure on public Wi-Fi, and supporting high-speed access to content from over 100 countries. Be sure to sign up via the exclusive link for CD Media audiences to receive an extra 4 months for free. For 150 million grueling years after the Big Bang, the universe remained engulfed in a profound night. However, piercing through that darkness, gravity began to awaken. Once matter became electrically neutral and less chaotic, gravity finally had the opportunity to pull the hydrogen clouds together. The hydrogen atom was floating in the void, thinking it had escaped the chaos after acquiring an electron. Suddenly, an invisible string tightened across space. Atoms stopped flying haphazardly as gravity silently and meticulously gathered them, much like an artist collecting grains of sand to sculpt a statue. Yet, as the accumulated mass grew larger, that gentleness disappeared. Hydrogen felt a pulling force beyond its resistance, sweeping it into a gigantic vortex. Before its eyes, an atomic cloud spanning thousands of light years appeared, overwhelmingly massive. Hydrogen saw others like itself, heading straight toward a mysterious, increasingly dense focal point. Space suddenly became suffocatingly cramped. Now, billions of tons of gas collapsed onto each other, creating an immeasurable weight. When the core of matter contracted small enough, gravity executed its mission of crushing everything. Our hydrogen atom was lucky enough to be trapped in the outer shell. From that position, it witnessed the brutal scene unfolding in the core, where the pressure was unimaginably high. Its friends were squeezed so tightly that the electron shell they had fought so hard to obtain was once again stripped away. Everything was forced back into a bare state under a pressure exponentially more cruel. At this moment, a fierce battle between gravity and internal pressure erupted. Remember that every proton carries a positive charge, and according to the laws of nature, like charges will always repel each other. For hundreds of millions of years, electromagnetic repulsion was an invisible but solid wall keeping the nuclei at a safe distance. But faced with the crushing weight of the massive matter collapsing inward, that wall had to yield. The brutal compression turned the core into an enormous pressure cooker, leaving the protons with no escape and forcing them to fuse. Do you remember the gluons, the super strong glue that locked the quarks inside each proton? Now, as the particles were compressed until they touched, that glue began to reach beyond its own borders. They realized there were neighboring quarks right next door. Immediately, these glue strands latched onto each other, locking everything together. In that fateful moment of fusion, a fraction of the mass was lost, transforming into an energy that tore through the eternal night. When the energetic dust settled, what emerged were no longer individual protons. They had merged and been reborn into a new, sturdier form, the helium nucleus. Meanwhile, a few protons mysteriously transformed into uncharged particles, acting as firm anchors to make the new structure even more durable. This was something the solitary hydrogen had never possessed. A perfect balance was established, and the very first star officially ignited. Hydrogen was no longer a lonely traveler, but had become part of a much larger structure. However, that star was not a tiny yellow-orange dot like the sun we know today. It was a deep blue giant, hundreds of times larger and thousands of times hotter. It stood like a colossal ball of fire, straining to maintain its shape against its own crushing weight. The nucleus witnessed a breathtaking spectacle. The light from the star not only warmed the immediate space, but also penetrated the surrounding foggy clouds. That glow awakened the dormant atoms, transforming the universe from a black and white picture into a dazzling, jewel-toned canvas. This was the dawn of all creation, but every glory has an end. For these fast-living giants, death usually comes much faster and far more brutally. After millions of years of maintaining a fragile balance, the hydrogen nucleus felt unusual tremors coming deep from within the core of its host star. At the core, the great furnace was beginning to run out of fuel. After numerous fusion reactions turning light nuclei into progressively heavier elements, the star reached its final limit. Iron, while the process of fusing hydrogen into helium released massive amounts of energy to sustain their shared home, iron was a dead end. To force two iron nuclei to fuse, the star had to expend more energy than the reaction could produce. The creation of iron drained the last bit of energy left. Wherever iron appeared, the fires died out. But that was not all. When nuclear fusion occurs, it generates a massive outward flow of energy from the core, counterbalancing the gravitational pull at the center that drags other matter inward. Now, without this counterbalance, gravity completely won out, and the celestial body collapsed instantly. Billions of tons of matter crashed into the center at an unimaginable speed. Our hydrogen atom felt as if the ground beneath its feet had suddenly vanished. However, when all this matter nearly struck the dense, solid iron core, an earth-shattering rebound occurred. Much like throwing a rubber ball forcefully onto a concrete floor, it inevitably bounces back. The pressure compressed the matter to an extreme limit without fusing it, causing it to violently rebound into a massive shockwave that wiped out everything in its path. In an instant, a brilliant halo enveloped everything, shredding the primordial darkness of the universe. Today, we call such an explosion a supernova. Hydrogen was hurled away by the destructive force, riding the debris blown out from the epicenter of a catastrophic blast. In that moment, countless neutrons and lithium particles shot out at terrifying speeds. Because these neutrons carried no charge, they acted like ghosts, passing right through the protective barriers of the surrounding iron atoms. Normally, a stable iron nucleus has a balanced ratio of protons and neutrons, often 1-1 or slightly more neutrons, serving as the glue to bind the protons. But now, it was bombarded by dozens or hundreds of neutrons packing themselves inside. The iron nucleus became heavy, bloated, and extremely unstable. Incredibly, those neutrons transformed themselves into protons, forging precious elements never seen before, such as gold and silver. Iron originally has 26 protons. If 21 added neutrons converted into protons, the proton count would rise to 47, turning the iron into silver. Similarly, when the proton count reached 79, iron turned into gold. Our hydrogen atom did not partake in this. It looked back at its birthplace, which was now just a colorful, expanding cloud of cosmic dust, a nebula. But right at the epicenter, it shockingly noticed a silent, pitch-black void. The brilliant rays of light from the explosion vanished, as if falling into an abyss when they struck that core region. Regardless of what it was, our little traveler had to embark on a new 10,000-mile journey once again. After the brutal explosion of the first star, the hydrogen atom fell into a deep slumber lasting hundreds of millions of years. The debris from the explosion did not disappear. Carrying the ashes of the old star, it wandered through the darkness for hundreds of millions of years. During this time, gravity began a grander task. It not only gathered lone atoms, but also molded those precious metal-filled dust clouds into new, blazing spheres. These new star clusters and massive gas clouds formed the primitive structures of galaxies. Upon waking, hydrogen no longer found itself alone in the murky darkness. A breathtakingly glorious sight appeared before it. The 1 billion-year-old universe had completely transformed. The little traveler found itself drifting on the outskirts of a swirling city of light, a young galaxy brimming with boiling energy. Everywhere, billions of stars sparkled like diamonds on black velvet. Space was now filled with vibrant ribbons of pink, purple, and blue from dusty nebulas. What had happened? Instead of becoming part of a new star, galactic winds had pushed the hydrogen far away, sweeping it into a vast cosmic ocean. The hydrogen atom entered a region of space so sparse it felt as though it were the only entity in existence. On this journey, hydrogen accidentally encountered a brilliant halo shooting out from the two poles of a majestic entity at the center of a distant galaxy. Looking closely at that radiant focal point, the little traveler realized something was violently sucking all matter into a spiral of death. In truth, it was a supermassive black hole, an invisible monster weighing millions, even billions of times more than our sun. Remembering the past when its mother star exploded, hydrogen recalled seeing light plunge into a silent black void like falling into an abyss. But the thing before it was far more terrifying. Here, light was bent into bizarre spirals, and waterfalls of gas and dust were shredded before vanishing into a bottomless chasm. The hydrogen atom didn't know when this entity formed, and even today, we have yet to fully decipher it. Although it clearly felt the distant pull of the abyss, the terrifying velocity from the ancient explosion allowed hydrogen to glide past like a ghost, escaping the deadly zone of influence by a hair's breadth. Wandering in the void for a few more billion years, the little traveler accidentally witnessed another bizarre spectacle. In the deep darkness of a stellar remnant system, a red giant was being frenziedly devoured by a cold, tiny blue entity. This small entity was a neutron star, the dense core left over from a celestial explosion in the past. Though its diameter was only the size of a city, its power was absolutely horrifying. It extended invisible, octopus-like tentacles, stripping away the outermost gas layers of the poor, towering red giant. Hydrogen watched in horror as swirling cascades of matter were swept into a vortex, forming a blazing accretion disk around the bloodthirsty corpse. The more matter it sucked in, the faster the neutron star spun. Reaching an extreme velocity, it shot out devastating X-rays, sweeping across space like lighthouses from hell. The pressure and temperature at the point of contact were so massive that they reminded hydrogen of the crucible inside its giant blue mother star from long ago. But here, there was no peaceful birth of new life, only deprivation and destruction. When the greedy entity swallowed more matter than it could handle, the final balance collapsed. A fatal collision erupted. Space trembled as gravitational waves tore through the fabric of the void, unleashing an immense amount of energy and scattering the heaviest elements like platinum and uranium. Hydrogen was once again blown away by the shockwave of this explosion. Gliding through the brilliant ruins, it felt pitifully small before these monsters of gravity. Yet, this fateful nudge pushed hydrogen out of the desolate abyss between the island universes of light. It began a journey toward a blue spiral ribbon, drifting lazily in the stellar ocean, the Milky Way. The Milky Way, the galaxy housing Earth, was conceived at the dawn of the universe over 13 billion years ago. Now it had matured, taking on a clear spiral structure with sweeping stellar arms spinning through space, reaching the 6 billion year mark. Hydrogen was swept into a cloud of gas and dust, collapsing under its own weight at the edge of this galaxy. It, along with countless other atoms, was squeezed tightly in a chaotic vortex. Deep within the core, the pressure and temperature rose to absolute extremes. Suddenly, a blinding flash flared up, tearing through the darkness of the void. The primordial sun had awakened. The little traveler found itself inside a massive, flat disk of matter swirling around the new star. Here, it witnessed an extraordinary architectural process. Under harsh heat, dust particles full of heavy elements like iron, silicon, and magnesium continuously collided, generating the binding energy to forge everything into a unified mass. Over time, they accumulated and grew into sturdy, rocky planets. But for a feather-light gas atom like hydrogen, there was no place to stay in this inner region. The first solar winds began to sweep across like a giant broom, blowing everything light and weak far away. The heat source from the sun gradually receded and faded. Ahead, a massive construction process was underway. Primordial icy cores were frantically building themselves up. They used their strong gravitational pull to capture matter along their path. After devouring billions of its fellow hydrogen atoms, these massive gas spheres began to dominate the outer perimeter. It thought it would settle there, but the tremendous gravitational pull from the large planets acted as a slingshot. The little traveler was hurled to the outermost edge of the star system. It became trapped in a thick, icy crust enveloping the distant frontier, where billions of rock fragments drifted in eternal darkness. Here, hydrogen was imprisoned in a rigid lattice of water crystals. At a distance of trillions of kilometers, the sun was just a cold speck of light, lacking the strength to warm this new home. Hydrogen slumbered in absolute silence for millions of years until a fateful event occurred. A passing star strayed near the outskirts of the solar system. The gravitational pull from this stranger acted as a gentle nudge, disturbing the orbits of thousands of ice blocks. The ice block containing hydrogen lost its momentum, leaving the safe zone, and was pulled by the sun's gravity into a freefall toward the center. As it ventured deep into the inner region, the cold ice block began to change shape. Under the intense heat radiating from the host star, the icy crust sublimated, shedding its dusty ice coat to reveal a dazzling tail stretching millions of kilometers. At this point, the world officially called it a comet. From its vantage point, hydrogen saw Earth, which at the time was going through an incredibly violent and extreme phase. About 4.5 billion years ago, our planet was not blue at all, but a glowing red sphere of magma beneath a dark, hazy sky. Rivers of bubbling magma flowed through an atmosphere thick with toxic gases. Most notably, the hydrogen atom witnessed the birth of the Moon, a Mars-sized planet slammed into Earth. The horrifying collision tore apart the crusts of both bodies, launching billions of tons of molten rock into space. From that fiery wreckage, a satellite gradually formed, orbiting the trembling, young world. But this reunion was fleeting. On its way back out, hydrogen's comet accidentally fell into the crosshairs of the gas giants. Like a cosmic slingshot, the immense gravity from these giants provided a boost that hurled the comet back into the dark belt. Hydrogen sank back into hibernation, carrying memories of a fiery world waiting to be rescued. Millions of years passed, and gravitational disturbances in the outer region once again pushed hydrogen's comet onto an inward journey. With every orbit, the solar system donned an astonishing new look. Earth began to cool, forming a solid, rocky crust, but it remained a barren and deadly planet. Then, a period of fierce bombardment began. Millions of meteorites and comets from the outer edges were flung into the central region, crashing straight into the rocky planets. hydrogen watched countless other ice blocks plummet toward Earth like arrows of light. Instead of destroying, these collisions brought an invaluable gift: water. Every ice block shattering on the scorching surface released water vapor into the air. That vapor rose high, cooled, and condensed into rains that lasted for thousands of years. Hydrogen felt a change in rhythm. Volcanic eruptions still persisted, but Earth began wearing a hazy coat of clouds. Through each of the comet's life cycles, hydrogen saw the sky gradually shift from a gloomy orange to the ashen gray of continuous downpours. And then, on a fateful day about 3.8 billion years ago, the little traveler's journey came to an end. Earth's gravity now acted like a giant hand, snatching the icy celestial body. Instead of gliding past like before, its orbit was completely bent, pointing straight at the ground. The ice block containing hydrogen plunged into the atmosphere. Extreme friction caused the outer shell to burst into brilliant flames, turning the cosmic traveler into a blinding streak of light. The ice block exploded, but when the dust settled, hydrogen found it was no longer trapped in a rigid crystal lattice. The hydrogen atom had melted, blending into a vast ocean, warm and rich in minerals. In those waters, hydrogen drifted effortlessly alongside molecules of carbon, nitrogen, and phosphorus. It had no idea that right here, life had officially begun. At the bottom of the deep ocean, where numerous hydrothermal vents erupted from the Earth's crust, miraculous chemical reactions connected hydrogen and its atomic friends. They formed countless complex molecular chains and gradually evolved into the most primitive single-celled structures. That spark of life persistently multiplied, learning to harness sunlight and oxygen to transform the world over billions of relentless years. And then, over 500 million years ago, plants began to blanket the continents in green, while the first animals emerged from the ocean depths. Ancient fish with pectoral fins adapted into sturdy limbs took their first faltering steps onto the muddy shores. It was a historic moment when lungs replaced gills, and the atmosphere officially became their new home. Through the river of time, the world endured brutal periods of rise and fall. Hydrogen flowed through the veins of giant reptiles that ruled the land, only to witness their demise under a rain of fire from a meteorite. But the spark of life never surrendered. When the giants fell, a resilient group of small mammals began to rise from dark burrows. After millions of years of silent evolution, a primate with curious eyes and nimble hands stepped out into the light. These were our ancestors. After a more than 10 billion-year expedition through stellar forges and freezing abysses, hydrogen's journey finally reached its destined stop. The little traveler wove itself into chemical bonds, transforming into part of a water molecule and then curled up inside the primordial DNA double helix. From the primitive ocean, hydrogen flowed through the veins of countless bizarre creatures, and now it resides within every human cell. Creatures who look up at the night sky, searching for their own origins. Looking back at the road traveled, we see that all the terrifying events, from the dawn of the Big Bang to brutal cosmic explosions and collisions, were all like an elaborate preparation for humanity's presence today. Hydrogen is a piece of cosmic history that is quietly writing its most glorious chapter right inside every living entity on this blue planet. The 10,000-mile journey has concluded, leaving behind